Welcome to solverfy.
For this problem on the topic of gravitation, we are asked to determine the mass of the Earth if we know the period and the distance of the Moon from the Earth. So we know the period of the Moon and we know the distance of the Moon, and we can calculate the speed of the Moon's orbit as v is equal to 2 pi r, where r is the radius of its orbit, divided by t, where t is the period of its orbit. But we also know that the speed can be calculated for any Earth satellite by v is equal to the square root of the universal gravitational constant g times the mass of the Earth, me, divided by the radius of the orbit, or the distance for the satellite from the center of the Earth, r. Now, equating these two equations, as we've done, means we can rearrange and make the mass of the Earth the subject of the formula. So me becomes 4 pi squared r cubed over g times t squared. So here r is the distance of the Moon from the Earth. Now, since we know these values, we substitute them in and we can find an estimation for the mass of the Earth. So this is 4 pi squared, and r is 3.84 times 10 to the 8 in meters, and that's cubed, divided by the gravitational constant g, which is 6.67 times 10 to the minus 11, and that's Newton meter squared per kg squared, multiplied by the period, and we know the period of the Moon is roughly 1 month, which is 27.4 days, and we'll convert the days into seconds to keep everything in SI units. And there are 86,400 seconds per day, and this period is all squared. And so now if we compute this value, we get an estimation for the mass of the Earth to be 5.98 times 10 to the power 24 kg.